So when it comes to graphics file devices, there are basically two broad categories of devices. One is called vector devices or vector formats, and the other format is called bitmap. So vector formats are most useful for things like line graphics. So if you have a scatter plot and maybe you draw a regression line through it, these are line graphics. They're not like natural scenes or images of photographs or things like that. And so these types of graphics are usefully kind of generated using vector formats because they resize well. So if you have to take the image and kind of make it bigger or smaller, it won't get distorted, and the quality of the graphic won't suffer. For example, the PDF format is very portable. You can use it on almost any platform that's out there right now, and so it's a good format, a general purpose vector format. Vector formats are typically not very good if you have a plot that has a large number of points, because every single point has to be represented by a piece of information in the file format, and so these files tend to be extremely large if you plot a lot of different points to a vector format file type. Scalable vector graphics, or SVG, is a popular format for web-based plots. It's useful because it supports things like animation and interactivity in the plot, and almost all web browsers recognize the SVG format now. Windows Metafile is a vector format that's available only on Windows. And you may see older files lying around that are in the PostScript format. This is kind of a predecessor to the PDF format. It's not used very often, but you may see it around. In the bitmap format file formats, there are a few common ones. Probably the most common is PNG, which stands for Portable Network Graphics. And so basically, bitmap formats represent plots or images as a series of pixels, essentially. And so they're very good for plots that have lots of different points, because they'll be very efficiently represented in a bitmap format. PNG in particular is good for things like line drawings or images with solid colors. It uses a lossless compression algorithm so that the file sizes tend to be small, and pretty much every web browser can read PNGs now. So they're good for web-based plots. JPEG you might be familiar with if you have a digital camera or something like that. They're very good for things like natural scenes, which don't have solid colors but have kind of lots of like gradients of color. It uses a lossy compression algorithm, so the file sizes are very efficient and very small. And they're also good for, just because it's a bitmap format, it's good for making plots with lots of points. Bitmap formats in general do not resize well, so when you create a plot and you try to make it bigger or smaller, they can distort the quality of the image. And so generally speaking, you should not resize bitmap plots after they've been generated. JPEGs, of course, can be read by any computer and any web browser. So they're very useful for that kind of for web-based plots. They're not very good for line drawings because if you create a line drawing in JPEG, you'll see some aliasing in the lines. TIFF is another older format for bitmap files. It supports lossless compression. It's very commonly used. Still, BMP is a native bitmap format for Windows, and it's commonly used for things like icons. So it's possible to open multiple graphics devices, so for example, you might want to create 3 or 4 different plots to look at the same time, and the way to do that is to have, say, 3 or 4 different screen devices open, so the way you can do that is you can launch graphics devices explicitly. You can launch the screen device, for example, on Mac by calling the quartz function multiple times, and then you'll open multiple graphics screen devices. But you can only plot to one device at a time. And so the graphics device that you plot to is the active graphics device, and you can figure out which graphics device is the active one by calling the dev.cur function, or dev stands for current, and that function will return an integer that tells you which graphics device is currently active. So every graphics device is assigned an integer that's between 2 and 2 and up, basically. So there's no graphics device that has the number 1. So every graphics device gets an integer, and you can change which graphics device is the active graphics device by calling the dev.set function. And dev.set takes an integer value, which will switch you to the graphics device that corresponds to the integer that you give it. So you can switch back and forth between the graphics devices using the dev.set function if you need to. Finally, it's possible to copy plots from one device to another, and this is probably most commonly used when you've created a plot on the screen and you decided that you really like it, and then you want to put it into a file. And so there's two ways that you could do this. One is that you could, if you've saved the code that makes the plot on the screen, you can just open up a file device and then cut and paste the code into R, and then close the file device, and then you've got your plot in a file. But a faster way, and sometimes more convenient, is to copy the plot from the screen device to the file device. And you can use this with the dev.copy function, which just copies plots from one device, from any device to any other device. But if you specifically want a PDF file, there is a function called dev.copy to PDF, which will take the screen device and copy it directly to a PDF file. Now, it's important to note that copying a plot is not an exact operation, so the plot that you end up with in the file may not look exactly like the plot that you saw on the screen. And so there may be some adjustment that you have to do. So here's some code that just creates a plot on the screen. This is the old faithful geyser data that comes with R. And then I want to copy it to a PNG file. So I want to create a PNG file on my computer that contains the plot that I'm looking at on the screen. So I can call dev.copy. The first argument to dev.copy is the function that opens the file device. So in this case, this is the PNG function. And then I just give it a file name, which is needed to create the file. So I just call it geyserplot.png. And then once I've copied the plot, I still need to close the PNG device with dev.off. So once I call dev.off, there should be a file on my computer that's going to be in a PNG format, and I can send it to someone, or I can include it in a presentation. So that's a quick summary of the graphics devices in R. The basic bottom lines are that every plot must be created on a graphics device, and usually this is the screen device, but it's useful for exploratory analysis. But if you want to preserve a plot or send it to someone, you have to create a plot in a file device, and there are a variety of different file formats that you can use. There are vector formats like PDF and SVG, and there are bitmap formats like PNG and JPEG that you can choose from.